So here we are going to look at example 7 from notes chapter 3. So what we have in the question is a tennis ball of mass m1 moving with initial velocity u1 collides with soccer ball of mass m2 initially at rest. So we have two balls, tennis and also soccer ball. One is moving with initial velocity u1 and another one is initially at rest. Maksudnya it is not moving. So according to the diagram here, your M1 is moving along x-axis to the right horizontally and it collides with the second ball M2 which is initially at a rest. After the collision, the tennis ball is deflected 50 degrees from its initial direction with a velocity of v1 as shown in the figure. Alright, so this ball 1, after it collides with M2, it is deflected downwards in this direction at 50 degrees below. Suppose that M1 is 250 gram, M2 900 gram, and U1 is 20 ms negative 1, and V1 is 4 ms negative 1. Calculate the magnitude and direction of the soccer ball after the collision. So basically, we do not know what happens to this ball. We do not know the direction it went. So we are going to find the magnitude and also the direction. It is not given in the image here. Kita tak tahu dia ke atas ke atau dia ke bawah ke, dia lurus ke, kita tak tahu juga. However, based on ball 1, we know that this is a 2D component question sebab dia ada data deflected di antara X dan juga Y here. Alright, so we are going to have two summation P initial along X and also summation P final along X dan juga summation P initial along Y dan juga summation P final along Y. So we are going to use the conservation of momentum along X component and Y component. Since kita ada dua equation dekat sini, as you can see, even dalam soalan pun kita nak cari magnitude dan juga direction. We are looking for two things from the ball 2 ini. So kita nak tahu velocity 2 berapa dan juga direction dia. Velocity 2 berapa dan juga direction dia berapa dekat sini. Kita nak cari V2 dan juga theta here. Okay, so what shall we do is we are going to start with the X component first. I'm going to put M1 U1 along X plus with M2 U2 along X is equals to M1 V1 along X plus M2 V2 along X. So as you can see, the mass one is given in gram, so you have to convert it to kilogram. So nak convert pergi kilogram, bahagi sahaja dengan 1000. So you will end up with 0.25 kg multiply with U1 along X, and as you can see, your object 1 is already moving along X-axis. So whatever velocity that it is moving, 20 meter per second is along X-axis. So kita akan terus masukkan 20 dekat sini. 20 and then plus with M2 adalah 0.9 kg. Initially it is at rest, so 0. Tiada pergerakan along X maupun Y. And then M1 is 0.25, V1 along X. So this is my V1. Kita nak along X, so dia akan jadi V1 cos theta. Right, so V1 is given as 4 cos 50 here. Alright, and then campur dengan 0.9 V2X. Kita tak tahu V2 is moving in which direction. Let us assume dia berada somewhere sini. Contoh lah kan, contoh. Alright, so V2 along X dia akan ke sini. Alright, and then we make sure that the theta is touching the X-axis. So kita akan jadikan dia V2 cos theta. Okay, this is just the assumption yang kita buat. However, kalaulah dia bergerak, contoh V2 bergerak in this direction, contoh. Okay, kita punya V2 along X adalah negatif, betul tak? So it doesn't matter. Kalaulah dia ke sini, kita akan dapat jawapan yang negatif nanti. Okay, it's okay. So kita buat assumption sahaja dekat sini dia tengah bergerak in this direction. Okay, so now what you do is you press your calculator. 0.25 times 20 So we'll end up with 5 here. 5, this is 0, is equals to 4 cos 50 multiply with 0.25. So we get 0.64 plus with 0.9 V2 cos theta. So I'm going to simplify this. 5 minus 0.64. Bawa kawan ni ke kiri. So tolak. So you should get 4.36 is equals to 0.9 V2 cos theta. So we can still simplify this by bringing 0.9 here. So bila kita bawa, kita akan bahagi, divide 0.9. We should get V2 cos theta sebanyak 4.84. Right, this is V2 cos theta. So which is basically the velocity along X component kita. So we leave it here. Kita belum selesai. Kita nak V2 dan juga kita nak theta. So next, what are we going to do is we are going to enter the Y component. Initially along Y sama dengan final along Y. So we are going to have M1 U1Y plus M2 U2Y is equals to M1 V1Y plus M2 V2Y. So what happened here is your M1 adalah 0.25. However, U1 along Y component, your object initially were moving only along X sahaja. Along Y kita tak ada pergerakan. Maksudnya objek kita tak ada yang naik atas ataupun turun bawah. There is no motion along X axis. Therefore, this whole thing akan jadi kosong sebab no velocity along along Y. My bad, no velocity along Y axis. Okay, so we are going to look at what happened after the collision. After the collision, dia involve X component dengan Y component sebab dia ada theta here. So M1 adalah 0.25, V1Y adalah, this is your V1. So V1 along Y akan ke bawah. So we're going to have negative V1 adalah 4 sin 50. Then we're going to plus with M2 adalah 0.9. V2 along Y, kita assume V2 tadi bergerak di sini, betul? We make an assumption. So kalau tadi V2X ke sini, maksudnya V2Y akan ke atas. Ini adalah assumption kita buat. If you were to get negative, jangan risau, maksudnya assumption kita salah, dia sedang turun ke bawah. So it doesn't matter. Alright, so kita akan dapat V2 sin theta dekat sini. And then you press your calculator for sin 50 multiply with 0.25. So kita akan dapat negative 0.766 and then plus with 0.9 V2 sin theta. So saya nak bawa this one to the left here sebab dekat left ni ada kosong saja, so become positive. 0.766 sama dengan 0.9 V2 sin theta. And then I'm going to bring my 0.9 here. I'm going to divide 0.766 divide with 0.9. You should end up with V2 sin theta as 0.85. Alright, so you have got your V2 cos theta and V2 sin theta. Kita tak jawab soalan, soalan nak V2 sahaja dan juga theta. So what are you going to do is you're going to make your V2 as a subject. Okay, ini equation pertama, ini equation kedua. From equation 1, your V2 becomes 4.84 divided by cos. Oh no. We should make things simpler. So V1 adalah, I rewrite equation 1 adalah cos theta 4.84 and then equation 2 adalah V2 sin theta 0.85. Alright, so you can see kita ada cos dengan sin dekat sini. So cara senang adalah sebab dia adalah dua trigo yang berlainan, we are going to change them into a common trigo iaitu tangent theta. Tangent theta adalah opposite over adjacent here. Alright, opposite over adjacent. Okay, so cos theta is adjacent over hypotenuse. Sin theta pula adalah opposite over hypotenuse. Right, so these two can be related into tangent by dividing the sin theta over cos theta. Bila kita bahagi, sin theta adalah opposite over hypotenuse dibahagikan dengan adjacent over hypotenuse. What are you going to end up with adalah opposite over adjacent. Hypotenuse cancel each other. Okay, opposite over adjacent adalah sebenarnya leads to tangent theta. Ini adalah identity sebenarnya. So what I'm going to do is I'm going to take my equation 2, I'm going to divide my equation 1. So V2 sin theta divide with V2 cos theta. So sin theta ni equals to 0.85 tadi bahagi dengan 4.82. Kiri kanan dua-dua kena bahagi. Alright, so sin over cos dapat tangent. So V2 bahagi V2 dapat 1. So dapat tangent theta sahaja dekat sini. 0.85 divide 4.84. You will end up with 0.176. And then shift tangent. You should get your theta as 9.96 degree. Alright, 9.96 degree dekat sini. Apa yang kita nak buat next adalah kita nak masukkan dia ke dalam mana-mana equation untuk dapatkan nilai V2. Let's say masukkan dalam satu. V2 cos 9.96 sama dengan 4.84. 9.96 cos answer 4.84 divide answer. You should get V2 as 4.91 ms negatif 1. So dah ada nilai. So V2 adalah 4.91 ms negatif 1, theta kita adalah 9.96 degree above positive x axis. Maksudnya dia bergerak di sini. Ini theta kita. Ini V2 kita. This is where your soccer ball is located in the first quadrant.